Morning students, so let's start the second module, and the syllabus includes index properties and permeability of soil. Index properties mainly deals with sieve analysis, then hydrometer analysis, relative density, consistency, and the experiments to find these consistency parameters. Then classification of soil. Then the second part includes permeability of soil. Okay, so first we can start with index properties. Okay. So mainly the soil properties are classified as index properties and engineering properties. The example for engineering property are permeability, compressibility and shear strength. This will be discussed later. So first we can discuss about index properties. Okay, so index property means these are the properties of soil which are not of primary interest to the geotechnical engineer, but these are the indication of engineering properties. Okay, that is, these index property are not much important as far as civil engineer is concerned, but these index properties are indication for the engineering properties. So this engineering property are very important for a geotechnical engineer. And the example for engineering properties are permeability, compressibility and shear strength. Okay, so permeability means ability to pass water, and compressibility means it is the deformation produced in soil when they are subjected to compressive load, and shear strength means ability to resist the shear stresses. So these are the engineering properties, and the properties which are indicating these properties like permeability, compressibility and shear strength are known as index properties. Okay, so simple properties which are required to determine the index properties are classification test. So using this classification test we are determining the index properties, and the soils are classified and identified based on the index property. So the main advantage of this index properties, using this index property soils can be classified and identified. Okay, so next we can look through what are the index properties of soil. The main index properties of coarse-grained soils, that is the main index properties of sand, are particle size and relative density. And for fine-grained soil, the main index properties are Atterberg limits and consistency. So fine-grained soil means clays. So the main index properties of the soil are particle size, relative density, Atterberg limits and consistency. Okay, so we can discuss one by one later. And the index properties of soil can be divided into two types. They are soil grain properties and soil aggregate properties. Soil grain property means the property which are dependent on the individual grain of the soil, and it is independent of the manner of soil formation. That is a property which is depending on the individual grain of the soil is known as soil grain property, and the property which are dependent on the soil mass as a whole, that is known as soil aggregate property. Okay, so the soil grain property means it depends only on the individual grain of the soil, and example are size and shape of the grains. And soil aggregate property means these are depending upon the soil mass as a whole, and it is influenced by the soil stress history and mode of soil formation and soil structure, etc. So first index property is grain shape. So we can discuss about grain shape. And the engineering properties of soil, usually every engineering properties of a soil depends upon the shape of the particle. Especially for coarse-grained soil, the engineering properties depends upon the shape of the particle. But even though there is no universally accepted grain shape classification, the following is the general classification, and it is not universally accepted grain shape classification. Okay. So first type of shape is bulky grain, the particle with bulky grains. So bulky grain means length, width and thickness are of same order of magnitude. That is, length, width and thickness will be of same magnitude. Okay, example sand and gravel, and these are formed by physical disintegration of rocks. Okay, and at this stage the bulky grains are angular. That is, at the point of formation, the bulky grains will be angular, and during transportation these sharp edges may be worn out and the grains become rounded, almost rounded, due to the transportation. Okay, and in between the two extremes of angular and round shapes, there are subangular and sub-rounded shapes. Okay, that is, at the formation the bulky grain means it will be angular, and during transportation the sharp edges will be worn out and grains become rounded. Okay, and in between there will be subangular and sub-rounded shapes. So this is first shape, that is bulky grain. Example sand and gravel. And the second shape means flaky grains. That is one dimension of grain, that is thickness is very small compared to other two dimensions. That is thickness will be very low comparing to length and width. That is flaky grain. So it resembles a sheet of paper. Example, clay soil. Okay. And the third one is needle shaped grain. That is one dimension of the grain is fully developed and is much larger than the other two. So, almost same to our flaky grain. Example, clay mineral like kaolite. Okay, so these are the important grain shapes. That is, this grain may be bulky grain or flaky grain and needle shaped grains. So next we can discuss about grain size. Okay, this I have discussed in the first module. That is, the grains are the soils are classified into fine grained and coarse grained, and these fine grained and coarse grained again subdivided into different category based on the size. Okay, so for classifying fine grained and coarse grained soil, the boundary is 0.075. Okay, that is the particle with the size less than 0.075 mm, that is known as fine grained soil, that is usually clay particle, and the particle with size greater than 0.075 mm is known as coarse grained soil. Okay, and this coarse grained soil means it may be sand or gravel, and again the sand and gravel are classified based on this boundary, that is 4.75. so the particle with size less than 4.75 mm it will be sand, and size greater than 4.75 mm it will be gravel. Okay, so this is the general classification. And this coarse grained again classified as sand, gravel. Sand is again classified as fine grained, medium and coarse. Fine grained sand means size between 0.075 mm and 0.425 mm. Then medium means between 2 mm and 0.425 mm, and coarse means 2 mm and 4.75 mm. And size greater than 4.75 mm is gravel, and gravel again classified as fine gravel and coarse gravel. Fine gravel means size between 4.75 mm and 20 mm, and coarse grain means between 20 mm and 80 mm. Okay, and in between 80 mm and 300 mm it is known as cobbler, and greater than 300 mm it is boulder. So this is the classification of coarse grain particle. And this fine grained again classified as silt and clay. Silt means the size in between 0.075 mm and 0.002 mm, and size less than 0.002 mm is known as clay. Okay, so this is very important, that is the size of clay means clay size will be less than 0.002 mm. Okay, silt means size in between 0.002 mm and 0.075 mm. So this should be remembered in your mind, this chart. Okay, so that is fine grained soil means size less than 0.075 mm. That is based on the 75 micron. The particle with size less than 75 micron. 75 micron means 0.075 mm. Okay, so less than 75 micron, that is fine grained soil, and greater than 75 micron it is coarse grained soil, and these are again classified into different subdivisions. So you should by heart this all sizes. Okay, so this is about grain size. So we have discussed about grain size, grain shape and grain size. Next can discuss about grain size analysis. So I will put this in the next video. Okay, thank you.